Hey, hello everyone. This is Carlos Olguera. Really happy to be back in the R2Con this year. Today we're gonna talk about using R2, of course, to uncover mobile app weaknesses. So the first thing would be to present myself, I guess, introduce me. So yeah, I'm Carlos Olguera and have double role here. So on one side, I am the project lead at the OWASP MAS, Mobile Application Security project at OWASP, and also same as Pancake, part of Now Secure and the research team. So yeah, today we're going to dive into a couple of things regarding R2 and mobile apps, which are all inspired by the OWASP MASTG. So first of all, just a really quick intro on, let's say you have an app, you're new to testing mobile apps, like testing security of mobile apps, or maybe not. So basically you would have an app. Let's see, this is a very representative app, right? It's like a WhatsApp or something like that, right? So just to give you a quick intro to the OWASP MAS project and the areas that we cover is, for instance, here you're analyzing this app and we tell you what's important, what you should look into. So there are several different areas which you will see here represented by several colors. So the first one is about cryptography. In this case, in this chat app, the messages should be encrypted. Then they should be securely stored also. So in this case, we see the app stores them in external storage, probably not a good idea. Then we have other kinds of storage. Maybe this app is also storing the pictures from the chats in the external storage on Android, which wouldn't also be a good idea. There are other things like maybe the app allows you to share with other apps, which could cause some trouble or not. And sorry. And then it could be also stored to some cloud or something like that. And also in this case we see it uses the camera, so potentially it could represent some privacy risk and things like that. So there are many things, many areas, and what the project covers is starting from a high level. We cover all these areas like storage, cryptography, authentication, networking, and as in this example we start with something very high level as insecure crypto is bad, right? But then we get more specific in the middle, like the MASWE. Those are mobile weaknesses, like surely you know CWEs. So similar to that, but just mobile specific. And in this case, we say the app uses weak encryption algorithms. So that's more specific than the one above. And then we get into the low level in the testing guide, Mobile Application Security Testing Guide, MASTG, where we see a specific test for testing cipher objects for DAS algorithm. So very specific. You will see that we have more than this. So not only we have the weaknesses, but we also have specific tests. And then the tests have demos, which is basically where we are gonna focus on today. The actual demos, like hands-on stuff. So the demos and the tests, they are related. So we have a test where we can see in our website at mas.owas.org. You can find, for instance, this test, and you will see that why we are testing. So there is an explanation why this is important, what are some relevant APIs related to this test, etc. Then you will have some specific tests and the output of the test, and then how to evaluate the results. And then if we already have some demos, we will also have some links there. And the demos are real apps. So this is based on these test apps that you can see here. We have them for both Android and iOS, and they have their own repo. They're very, very simple apps that look like the one you have on the screen right now. And every demo that we build is built using these apps. That makes it really easy to build additional demos and really follow what's going on when you're looking at the code. It makes also very easy to have like really small exercises or challenges, as you're gonna see in this presentation. So this is the cool thing, that since we have everything on the website, you can either clone the repo. I'm gonna just quickly show you here. Everything is on GitHub and OWASP MASTG. And you see we have several things here, like for apps, best practices, demos, we have tests, tools, techniques. There are many things, super good material here for learning, both beginners, experts, it really doesn't matter. And then we have everything here, like for instance, this is the tool page for Radare for Android, and here you have the description. And the cool thing is that in this case, in our context of the MAS project, we explain Radare from the mobile app perspective. So you will see that we have things about permissions, activities, receivers, everything that is specific to Android, and how you deal with that, how you handle that using Radare. So there's a lot of good information here. And then when we enter the demos and the tests, as you see here, I have them prepared, the ones that we are gonna analyze today. You will see that we are using the tool, we are referring, we're linking to the tool, we are using specific reversing techniques and things like that. And the MASTG covers all this information, so you can just come back anytime and read about everything. So what I wanted to show here is how easy it is when you have a demo that you can actually not only analyze like on your computer, but also you can run it, and you can also get the binary and then analyze it with R2. So if you want to run it, it's as simple as you will copy it, paste it, and run it. So you just have to clone these repos here for the apps, like the skeleton repos, and then you can copy paste the demos. So just to show you as an example, let's see this one here. We have demo 11, and here is the code. You will see that there's more things here. So we run the steps that are described in the test. Then we get an observation, which is the output of running that, and then the evaluation. But we'll get into this later. What I wanted to show you is that we can just take the code here, just copy it, and then we go to Xcode. This is the default code that we have in the app repo. So we can just go and replace everything here, and we can run the app. There we go. And this is cool, of course, if you want to also do dynamic analysis, and then you can just run the app. Of course, if you have a physical device, you can do the same. But in this talk, we are talking about R2, so we're not gonna run the app, but we are just gonna get the binary, open it, and explore it a little bit, right? To solve two challenges. So let me see, let's go here. So these are the demos. This is the first one, and this is about the uses of insufficient key size when using this specific API, sec key create random key. So we are creating random keys with insufficient key size, and we're gonna analyze this with R2. So you see here, this is the output of the app. So just if we run it, that was the same as you saw here. So it's the test here, and this is the original code, as you can see, but after it is compiled, you will see that you just have the binary, and then you cannot so easily read it as it is here, so that you cannot so easily see if the app is using a key that isn't right. So how do we do this? I thought we could try to, like, of course, you can just check. You have the links here for the demo and the test, and everything is solved in the MSTG. But this year is the year of AI, right? So we can go and try to let the AI help us. And if that's not successful, then we can do it ourselves. So let's see. Let me get to the right screen. You see, I have many screens here for you today. So let's go here. And since we are talking about Radare, Radare has NCP, which I'm not gonna go into detail because I'm sure Pancake will do that later. But here I'm using the latest version of the MCP here, and it offers you several tools. I have it open in VS Code, so we're gonna use VS Code and Copilot as our MCP client using this MCP server from R2. And so when you click here, you see that well, I disabled most of the other tools, just left the search here. But what's interesting, I can also get rid of this. Radar is here, and here I also disabled many of the tools. So depending on the case, maybe you want to have them all, or just a selection. For the use cases that I was working on, these were the ones that we needed. So better to narrow the scope whenever you can. So we can click OK here. And we wanted to do the demo 11 first. So actually I have it probably here. Let's see. Oh, it's the last one that I ran here. Yeah. So what I did was just prepare this short prompt. Please analyze the iOS binary as the 11 with Radare and test the following. And what you see here, this markdown, is what I just pasted it. It's from here, from the test. When you're on a test, this is for insufficient key sizes, which is the test corresponding to this demo. You can see it's 209 here, 209. And you click here, and then you get the markdown. So I just copy this over, and now we can see what the AI does. So let's go. Okay, but let's see. It needs to open the file first, otherwise it won't be able to do any of this. See, this is all failing. It has to open the file. Please open the file first. Oh, it's getting confused. No. Okay. The thing is, well, here you can also just go and edit this, open the file first. Okay. Did I remove that? Maybe open file. Yeah, see, that's why it cannot do it. Let's do this again now. Now it should acknowledge that tool. and use it. And it doesn't, oh, okay. Skip, stop. Let's start over with this one. Now that we know that it knows about that tool for opening files, and let's see. Now let's go, and I'm gonna allow for this session. And now it wants to do a lot of things. Okay, allow. List functions, it's not getting any output. Open file says it was successful and failed to render content. We don't know what this is. Okay, let's try GPT-5 and let's run the same thing again. Okay, yeah, that sounds all good. Go for it. I think it's better one in this case. And here, I think this is good, but for some reason it wasn't working. So I'm just gonna use this one. Oh, that was my bad. Okay. I think it should be like this. Yep. Okay. So yeah, sometimes it does need a little help. These are things maybe can be fixed at the MCP side, and sometimes it just I meant the MCP client side, server, sorry. Sometimes it's also the client, so it depends. Okay, let's continue. So now you see it got the functions, it found something and wanted to get the cross references, and then it went ahead and decompiled some function, and now it wants to disassemble another one. So let's go for it. More disassemble function, okay. Let's allow in this session so I don't have to click all the time. Just trying to look everywhere. You can always see like this if it's working and what it's getting. So now it's evaluating. It seems that it found some size, and now it's thinking about it. Okay, I think it got it. So let's see what the final output is. Let's go. Okay, good. So let's go up. Okay, here's what I found. I focus on security framework, key generation APIs, and any key size attributes. So open the binary, run the analysis, located the import stubs, including sec key create random key, very good. And then key findings, the binary import uses those APIs, good. No evidence of sysencrypt or import in imports. And then, yeah, here we're getting into that. It found the cross references, analyzed the functions in the same function just before this dictionary. During the setup, the code stores the literal 400 hexadecimal, so 1024. in a field consistent with key size attribute slot. It shows us that, you see, even with the added comment over here, and then it's interpreting the result, and this strongly indicates RSA key pair generation and use of a 1024-bit key size. The binary, it's a bit verbose, we have to say, but yeah, it's using that. So the evaluation per test criteria, this is considered insufficient, so the test is failing, and it tells us how to reproduce. So we could even try that, and we would open that file that is in samples MSTG demo 11, and then we can try to do this or something, AXT. There we go. S. So we seek over there, and then it says to do PDF. It's big, yes. We could take a look at it. Good. Open it like this, and it says PD 120. So let's see if that narrows it down. We should be looking at it here somewhere. Let's see here, create random key, and we should be seeing that 400 somewhere. So actually this could be a bit more specific in terms of letting us know where exactly it is. Maybe we can search for it. Oh, there it is. Okay. So there you go. Well, in this situation, actually, it took longer to do it with AI than manually because, well, if you know how to do it, then you can do it pretty quickly. Also, you can see how we did it here, and the steps that we followed were very similar. So we called AFL to list all the functions in Radare. Let me just do it like this again. So just to demonstrate that to you, that is similar. So we got, if I remember properly, we did something like this. So that is also the same, and then exactly the cross references, and then we just did like this, and we see that yeah, this is like the preamble of that function, like the first part. Then we are printing this middle part here, and then we are printing also the final part. And this way you're seeing that, okay, it's using this, we're seeing the 400 again here, and this is the way that we see that it's been used, it's been loaded. Of course, you can open the whole function and you can analyze it, but we're getting into the same conclusion. So that's what we see here after printing all those things, the uses of that function, the cross references to that function, and the use of the key size in bits as input for create random key in here. And again, we can see the 400, which is the is explained here in the evaluation. See, in the output, we can see that the key size bit attribute is set to 1024 bits, which is the 400 in hexadecimal in that register, and we just put it here so you can clearly see it here. So that's it for this demo. Now let's try to do the other demo, which is 15 over here. So we can just do the same. I'm gonna quit here, and I'm gonna just do something like this as well. In this case, it's gonna be 15, and this one is different. So I'm gonna also use the test. You see 211, which is here, about broken hashing algorithms. Let's get the test like this, and let's give it to the AI, and let's go. Now we should open it as before, analyze it, and search for the bad algorithms. Let's see. Okay, opened the file. Now it wants to analyze. I'm gonna put one. Okay. Wants to list some functions. Since this wasn't working before, I'm gonna take the same approach and replace it with this, so it gets everything. We can check it's getting everything. That's good. Wants to get some cross references, and we have some error. Let's see. It got the cross references, so it should be able to continue. Please continue. At least we see it was in the right path, so now it's evaluating. Very good. More cross references, and it's already decompiling some functions as well. So let's see what it comes up with. Wants also to disassemble, sure, and more disassembly. I mean, actually it could stop already because it already found those functions, right? Again, this is not gonna work. We'll check with Pancake why that's not working. Okay. Yeah, that looks good. Let's see if it finalizes now the analysis. Summarizing findings. Yeah, I guess it's concluding already. And it's looking good actually. Yep, okay. So let's see, before we don't have to wait. Okay, so it analyzed 15 and we'll pinpoint these things, right? So it found direct imports to common cryptos, CC MD5 and CC SHA-1, imported hashing functions detected at these addresses, and no imports found for the other ones. So it shows here, you see, it even, we don't have to do anything this time. It disassembled it for us. We can see it this way, and it evaluates, and according to the test, the usage constitutes use of broken hashing algorithms, so it's a fail. And yeah, of course. How to reproduce locally, open the file, and you can do these things. So we can do the same, like in here. Actually, oh, they are, I didn't copy it. And then we can do this as well. It found it there as an import, and this one as well, and it also tells us to do this, and that's also working. It's finding everything, so I'm not gonna continue. But yeah, the same as before. If you follow the demo, you will see again the original code, the steps, and you see that in this case, we used AFL to list the functions starting with CC, and then we get the xrefs to MD5 and then to SHA-1 and you show the usages. And that is what you can see in here. And you can see exactly the same as the AI showed before. And same conclusion as the AI. So did a great job this time. All right, I think that was everything I had. We covered the 2 demos, and yeah, this is me again. This is the project. We don't really have this thing anymore, so but you can use any other social media platform like Mastodon or Blue Sky and follow the same handles, and otherwise you can check here in the website. So here's some reference for you, and that's it for today from my side. Thank you very much and enjoy the conference. Bye bye.